Here's an interesting story to understand ratios better. It's about two good friends, Zen and Zara. Zen was out of cash one day and decides to ask Zara for money. Zara willingly says yes and asks how much. Remember, the ratio of the amount of cash taken to the amount of cash returned should be 1:1. It means that the cash returned must be equal to the cash taken. So Zen says he needs $100. Zara readily agrees, and then Zen tells her that he will return her 100 cents tomorrow. Now Zara starts wondering. She says to herself, I gave Zen 100 and he is returning 100. So the ratio remains 1:1. But it doesn't seem right. So after giving it a thought, she tells Zen that he should return $100 and not 100 cents. So ratio is a comparison, yes, but between quantities with the same units. Because if the units are not the same, comparison does not make sense. The ratio in this case is not 1:1. Now your basics of ratios are clear. But wait, there's a little more to it. Look at these two people. Yes, they look really thin. Let's look at the heights and weights. The first person's height is 120 centimeters and his weight is 50 kilograms. The second person's height is 180 centimeters and his weight is 75 kilograms. 75 kilograms is clearly more than 50 kilograms. Does it mean the second person is fatter than the first guy? Can we arrive at that conclusion? Just comparing the weights of each would be incorrect. We cannot just look at the weight, we need to look at the ratio of the heights and weights. Yes, the ratios of the heights and weights of each. The ratio in the first case would be 120 over 50, and the ratio in the second case would be 180 over 75. These are the quantities we need to compare if we need to arrive at a fair conclusion. And guess what? Both these ratios are equal. Both can be reduced to 12/5. So the second guy is not fatter than the first guy. When the ratios are compared, you realize that they are proportionate. But coming back to our earlier point, I had said that ratio should be a comparison between similar quantities with the same units. Here, the height is in centimeters and the weight is in kilograms. So how did we take these as valid ratios? Well, here's another important point. Here, we are comparing two ratios, not two quantities. While comparing two ratios, the units of the numerator of the ratio can be different from the units of the denominator of the ratio. You can look at it this way. Here, we are comparing centimeters by kilograms with centimeters by kilograms. And in the first example, we were looking at just one ratio in which we were comparing its numerator to the denominator. Hence, the numerator and the denominator had to have the same units.